Okay, let's take a look at section 7.5, solving equations with radicals and exponents. So now when we're going to take a look at some equations with radicals, we have the odd root property. If n is an odd positive integer, then x to the n equals k. So that's the third root, so there is one real solution. For example, when you look at this x to the third equals 27, you can rewrite that as x is equal to 3 to the third. Take the 1/3 root of both sides, and you'll get that x is equal to 3. Number 2, we have x to the 5th equals 32. To solve that, you're going to subtract the 32 from both sides, get a negative 32. So x to the 5th is equal to negative 2 to the 5th. Again, raise that to the 1/5 power, or take the 5th root of that. You'll get that x is equal to negative 2. Number 3, I have x minus 2 raised to the third equals 24. So again, I'm going to raise both of these to the 1/3 power. So this becomes x minus 2 is equal to the third root of 24. Remember, 24 is the product of 8 and 3. So we have x minus 2 is equal to the third root of 8 times 3. The third root of 8 is 2, so this becomes x minus 2 is equal to 2, third root of 3. Add the 2, the answer is x is equal to 2 plus 2, third root of 3. Number 4, subtract the 1 from both sides. 243a to the 5th equals minus 1. Divide by 243. And you have a to the 5th is equal to minus 1 over 243. And look at that as then take the 5th root of both sides. So a is equal to the 5th root of negative 1 over the 5th root of 243. Now, because it's an odd power, you can have a negative 1 under the radical, because negative 1 times negative 1 times negative 1 times negative 5 times is going to be a solution to this problem. So this becomes negative 1 over the 5th root of 243 is going to be 3. And we can look at our calculator to find those roots. If you want to take a look at your calculator, go to Math. Then if you arrow down to number 4, that's the third root. Number 4 is the third root. Take a look at number 5. You'll see an x in front of the radical symbol. To use that, you'll enter your indices first, then go to Math, pick number 5, hit enter, and substitute in your value of your radicand to solve that. Now let's take a look at x squared minus 4. When I add 4 to both sides, I get that x squared is equal to 4. Therefore, x is equal to plus or minus 2. Because both negative 2 times negative 2 equals 4, and 2 times 2 equals 4. And some of you kind of forget that on a few tests, so we need to remember that. Now we have the even root property. With the odd root property, we had one solution. It was either negative or it was positive. Now let's look at the even root property. suppose n is a positive even integer and k is greater than 0, then x raised to the n equals k is equivalent to x equals plus or minus the nth root of k. So in this case, we're going to get two solutions. The next one, if k equals 0, then x to the n equals k is equivalent to x equals 0, which is one solution. And now, if k is less than 0, meaning it's negative, then x to the n equals k has no real solution for the empty set. So let's look at these examples. I have x squared equals 10. So x is equal to plus or minus the square root of 10. For number 2, x to the 8, because x is equal to 0, I have one solution, which is 0. Number 3, when I take the fourth root of both sides, I get x is equal to the fourth root of negative 4. That's the last one, where the value of k is less than 0, so this has no real solution. In the next section, we will actually talk about imaginary numbers and the solution to that problem, but for right now, it has no real number solution. So note, an equation solution depends on the domain of the variable. So consider the solution for 2x equals 5. Is it rational? Is it an integer? Okay, it is rational. It is not an integer. Likewise, consider the solution for x squared equals negative 9. So you're saying the square root of negative 9, and that is imaginary. Let's take a look at solving some of these radical equations, or these exponential equations rather. So when I have the binomial x minus 3 squared equals 4, I can take the square root of both sides. So x minus 3 squared, square root equals the square root of 4. That gives me x minus 3 equals plus or minus 2. So I have x minus 3 equals 2, and x minus 3 equals negative 2. So here x is equal to 5, x is equal to 1. So the solution set for the first one is 1 and 5. Looking at number 2, to solve this one, when you have a binomial squared, add your constant to the other side, or do the opposite operation to get it on the other side. I'm going to have 7. Divide by that coefficient. So you have x minus 5 squared is equal to 7 halves. Take the square root of both sides, and you will have x minus 5 is equal to plus or minus the square root of 7 halves. Add the 5 to both sides, you get x is equal to 5 plus or minus the square root of 7 halves. Now keep in mind, at this point, you have to look at that solution and actually rationalize that denominator. So this becomes x equals 5 plus or minus the square root of 7 over the square root of 2. Multiply both numerator and denominator by root 2. And you'll get an answer of x is equal to 5 plus or minus the square root of 14 over 2. you want to write that as one number, you can multiply the 5 by 2, and that would give you that x is equal to 10 plus or minus the square root of 14 over 2. So your answers for this, x is equal to this 5 minus root 14 over 2 and 5 plus root 14 over 2. Number 3, I have x to the 4th minus 1. So again, I'll add the 1. X to the 4th equals 81. I've isolated my variable. Now I'm going to raise x to the 4th to the 1/4 power, and I will raise 81 to the 1/4 power. You can use your calculator to do that by taking the 4th root, or you can use the caret key, that caret key, and raise 81 to the 1/4 power. But x is then equal to 3. 3 to the 4th is 81, so that's plus or minus 3. So x equals plus or minus 3. Now let's take a look at some equations with radicals in them rather than the exponents. So if we're looking at equations involving radicals, if x equals 3, then x squared equals 9. The solution set to x squared equals 9 is x equals minus 3, x equals plus 3. But the solution set to the original equation is x equals 3. So the problem becomes when we square both sides, and this is kind of an important thing, you'll see it on the mid or on the final. This is where I tried to warn you it's kind of tricky. Squaring both sides of an equation might produce a non-equivalent equation that has more solutions than the original equation would have. These additional solutions are called extraneous solutions. So you need to check your solutions and make sure that they actually are equivalent. So you have to substitute them back in and make sure they work. When you solve an equation by raising each side to a power, you must check your answers. Raising each side to an odd power will always yield an equivalent equation. Raising each side to an even power might not. So you need to pay attention to that, and we'll look at that as we move through some of these examples. The first one I have is the square root of 2x minus 3 equals 5. So the first thing I want to do is isolate that term that has the radical in it. So to do that, I'm going to add 5 to both sides, giving me, whoops, sorry about that, the square root of 2x minus 3 equals 5. Now, in order to solve this, I need to square both sides. So I will raise both sides to the second power. That gives me 2x minus 3 equals 25. Add 3 to both sides, and you will get 2x equals 28. So x is equal to 14. Now you need to check that and make sure that that is true. So the square root of 2 times 14 minus 3 minus 5 equals 0. So the square root of 28 minus 3 minus 5 equals 0 is true. So x equals 4 is in fact a solution to that equation. Now in some cases you're going to have a radical, more than one radical in an equation. You want to raise it both sides to the power that cancels the radical. So in this case, this is the third root. So what we're going to do is raise both sides to the third power. So this becomes 3x plus 5 is equal to x minus 1. So 2x is equal to 6. So x is equal to 3. Now remember, an odd power will always yield an equivalent equation. You can substitute it in if you like. You're going to get 9 plus 5, or negative 9 plus 5 is the third root of negative 4 is equal to the third root of, let's see, negative 4. That should be a negative 6 there, sorry, and a negative 3, so you're substituting in a negative number. Okay, example number 3, again, square both sides. So I'll have 3x plus 18 equals x squared. You want to get all of the terms on one side of the equation set it equal to 0, so you can factor that quadratic. So I have x squared minus 3x minus 18 equals 0. And then to factor that, you can use guess and check or the rainbow method. If you use the rainbow method, you ask yourself what multiplies to negative 18, but adds to negative 3. And that would be plus 6 and minus 3. So the solutions for this would be x is equal to minus 6 plus 3. And then you want to substitute those in and see if they are in fact true. So substituting in, actually, this is, I have that wrong. Let me make a correction here. This is minus 6 and plus 3. Let me erase right here. Fix that. So I have x minus 6 and x plus 3 equals 0. So x is equal to negative 3 and 6. So when we check those, when I substitute in a negative 3, I have 3 times negative 3 plus 18 equals negative 3. So I have the square root of 9 equals negative 3. There's no way the square root of 9 can be a negative number, so I get 3 is equal to negative 3, and that's not a solution. Let's check 6. When I substitute that in, I have 3 times 6 plus 18 equals 6. So 18 plus 18, square root of 36 equals 6. That one is true. So x equals 6 is the solution to that radical equation. Now sometimes what will happen is you have 3 terms, 2 of which are radicals. So you might have to square both sides more than once. In this case, we're going to square it twice. It's usually easier to do this if you separate those 2 radicals by the equal sign. So I will add the square root of x plus 3 to both sides, or square root of x plus 2, sorry. So I'll have the square root of 5x minus 1 equals 1 plus the square root of x plus 2. Now when I square both sides, pay attention, on the right, I have a binomial, and I have to FOIL that. On the left, I'll simply have 5x minus 1. I'm going to write this out on the right-hand side so that those of you who need to see it can see exactly what I'm doing. So now on the right-hand side, I'm going to FOIL. So I will have 1 times 1 is 1. 1 times the square root of x plus 2. 1 times the square root of x plus 2 plus than the square root of x plus 2 squared. So remember, the square root of a squared is just a. So now, I still have my 5x minus 1 on the left. And on the right, I have 1 plus 2, square root of x plus 2, plus x plus 2. When I combine like terms, I have 5x minus 1 is equal to 3 plus x plus 2, square root of x plus 2. Now, isolate that radical that's on the right again. So get everything else on the other side. Subtract the x, so you're going to have 4x. Subtract the 3, so you'll have a minus 4 equals 2 times the square root of x plus 2. Now, divide both sides by 2. So you're going to get 2x minus 2 is equal to the square root of x plus 2. Now again, in order to get rid of this radical, we're going to have to square both sides again. So in this case, I'm going to square this side, square this side. Squaring that, I'm not going to write it all out. Remember, this is a perfect square trinomial now, so I'm going to have 4x squared minus 8x plus 4. And that will equal x plus 2. So I've squared both sides. Subtract the x from both sides, you're going to have 4x squared minus 9x plus 2 equals 0. And then you can either use the rainbow method or you can think about how to factor that. Some of you like guess and check, and that works just fine. This actually factors to 4x squared minus 8x minus x plus 2 using the rainbow method. Group the first 2, group the second 2. Remember to change that sign when you have that second grouping. You have to account for that negative. So now I will come back up here, factor out the greatest common factor of 4x. That's going to leave me x minus 2. Greatest common factor in the second grouping is a 1, leaves me with x minus 2 equals 0. So I have 4x minus 1 times x minus 2 equals 0. So x can equal 1/4 and 2. And now you need to check both of those solutions to see if they are in fact both true. So when we go back up to the original equation, I know this looks like a lot of work, but when you have to square both sides, it usually does entail many steps. The square root for this one, it is 5 times 1/4 minus then 1, which is going to be 1 or 4 over 4. And then minus the square root of 1/4 plus 2, which will become 8/4 equals 1. So I have 5/4 minus 1/4 gives me the square root of 1/4 minus the square root of, 9/4, which is equal to 1. Now when we look at our properties here, this becomes the square root of 1 over the square root of 2. minus the square root of 9 over the square root of 4. So that's a 4. 1 over 2 minus 3 over 2 equals 1. And that is false because that says negative 1 equals 1. So that one is false. Now you should go ahead and check the second value, which was a 2. And when you check that, you should find that that is in fact the solution, and that does come out to be true. I'm going to move along to finish the notes, hopefully, in a shorter period of time. So again, you should probably stop the video here and then work on this equation, come back, see the work I've done, and see if you get the same answer. Okay. At this point, you can divide both sides by 4, or you can square that 4 on the right-hand side. Just remember to put parentheses around the x minus 2 and distribute that inside. So that's what I'll do when I square both sides this time. I don't want to get those fractions. So in this case, I'm going to have 16 minus 8x minus 8x plus 4x squared equals 16 times x minus 2. So I have 4x squared minus 16x plus 16 equals 16x minus 32. Get everything on one side, so 4x squared minus 32x plus 48 equals 0. You can factor out a 4 here and get x squared minus 8x plus 12 equals 0. That factors to x plus, no, x minus. X minus 6 times x minus 2 equals 0. So your solutions look like they are x is equal to 2 and 6. Again, substitute those in, check, see if they're true. What you're going to find out is that x equals 2 is true, and then when you substitute in x equals 6, that is false. But take a minute and check those. You'll want to do that on both this chapter test and on the final exam, because you're going to see that that does show up to have both answers when only one of them actually works. Okay, equations involving rational exponents. So here I have x raised to the 2/3 equals 4. So just like before, I'm going to raise both sides to the reciprocal of that exponent. So I'll raise both sides to the 3/2. So you can see on the left, x raised to the 2/3 raised to the 3/2, power to a power, is going to give me 6 over 6, which gives me x. On the right-hand side, we can look at this as 4 to the 1/2 raised to the 3rd. 4 to the 1/2 is 2 to the 3rd, and that would be 8. Okay? Next one, let's take a look. This is w minus 1 to the negative 2/5, and that equals 4. And what I did with this one was I raised w minus 1 to the negative 2/5 to the negative 5 on both sides. So 4 to the negative 5. That's going to give me w minus 1 squared equals 1 over 4 to the 5th. We're going to get rid of that negative exponent. So now to solve this, I'm going to take the square root of both sides. W minus 1 is equal to plus or minus the square root of 1 over 4 to the 5th. 4 to the 5th is also 1024. So I have w minus 1 is equal to plus or minus the square root of 1 is 1 over the square root of 1024. Add the 1 to both sides, so w is equal to 1 plus or minus 1, the square root of 1024, which happens to be 32. So there are your answers for that particular problem. The applications problem says a diagonal of a baseball diamond. So I have a baseball diamond is actually a square 90 feet on each side. What is the distance from third base to first base? So here's third base, here's first base. So this distance, you can use the Pythagorean theorem. Some of you might actually remember 45, 45, 90 right triangles. That would be good if you did. You're going to see them again in advanced pre-calc. They're going to show up. So it wouldn't hurt to remember that 45, 45, 90, which has a ratio of 1, 1, square root of 2. So if you remember that, you know the length of that diagonal D is 90 root 2. If you've forgotten that, you can always take 90 squared plus 90 squared equals D squared. Use the Pythagorean theorem to solve that. That would give you the square root of 16,200, which gives you plus or minus 90 root 2 equals D. Remember, when we're talking about a dimension, a negative number is not the answer, just a positive number for that problem. So a summary of the methods, the strategy for solving equations with exponents and radicals is in raising each side of an equation to an even power. When you raise each side to an even power, you can create an equation that gives an extraneous solution. Check all possible solutions. When applying the even root property, remember that there is a positive and a negative even root for any positive real number. And for equations with rational exponents, raise each side to a positive or negative integral power first, then apply the even or odd root property. Positive fractions raised to a positive power, negative fractions raised to a negative power. And I actually think that is it for the notes for this section. Tomorrow we will have 3 worksheets in class, and tomorrow night another video. Have a good evening. I'll see you tomorrow.